All right, so like chapter 4, like we had 4 methods for solving, right? Factoring was like our go-to, but if it didn't factor, we had other options. So this chapter, we're talking more than just quadratics, right? We have cubics and quartics and quintics and everything else above, right? So in this chapter, we need more options as well. So we just got done with all of our factoring, but not everything factors. So this is like a stepping stone section to kind of get us to the next part of what do we do when they don't factor. Okay, so this is our stepping stone. This is all division. Today we're going to do long division. No whining. No whining. Long divisions today. And then Monday, my favorite is synthetic division. Synthetic division is algebra 2, okay? It is actually one of the easiest things you're ever going to do. Long division's harder. Not that it's that hard, but it's just harder. Synthetic division, when I teach that to you on Monday, you'll be like, oh my gosh, like, because it's totally different. It's nothing you've ever seen before. But like once we do a couple of them, you're like, oh, this is really easy. It's not bad. But the problem where I don't just do synthetic is it doesn't work for everything. So we have to use long division on some things. No. Yes. No. I don't think so. I don't think so. Yeah, they would be awful for Excel. All right. But guys, my number 1 rule for this section is no whining, okay? Those of you who say you've never learned long division, if you did that crazy, stupid lattice method or whatever they went through, and you guys kind of went through that phase of weirdness in math where they tried all kinds of weird things, I apologize. You guys went through all of that. I'm going to start with regular long division, no variables. Okay? Okay. Now, as I go through these 2 examples, I want to go nice and slow, methodical. The point I'm doing by going through this is I want you to see the process. Okay? Like I'm going to be asking the same questions over and over. I want you to see the process. Good? Yes? Don't just type this in your calculator. That's not the point. We want the process. Okay, but a lot of people try that. Okay. No, because when we get to with variables and stuff, you can't just type that in your calculator. So we're going with the process. So 672 divided by, that's your radicand right there, divided by 3. So we start with the 3 and the 6. How many times does 3 go into 6? Twice. So we put the number up top, and then you multiply. 2 times 3 is 6. And then what did you do from there? Do you guys remember? Before that. What do you do with the 6? You subtract. You subtract. And that's nothing. And then you would bring the next one down, and the process would start over. Okay, with long division, it's like you're doing the same thing over and over and over until you're out of things. Yeah. So we're just trying to, guys, at this point, we're trying to get the process down. So then you start again. What do you multiply 3, or how many times does 3 go into 7? 2 times. It goes 2 times fully, right? 2 times. And then you multiply. 2 times 3 is 6. And then you subtract. 7 minus 6 is 1. Bring down the next part. And you start again. You're seeing the pattern, the same process. Lily? I've seen people do that. Yeah, but not with what we're doing today. This is why I hate when elementary school teachers come up with these fancy like gimmicks for things, because it doesn't transfer into algebra. I know, I'm sorry. It's not your fault your teacher taught it that way. And it may work for long division, great. But when we're doing polynomials, it doesn't follow. Yeah, there's a disconnect from like the elementary teachers versus the high school teachers. There's a big disconnect. I'm sorry. It's exactly what that is. All right, so start our process again though. So how many times does 3 go into 12? 4. And then you multiply. 4 times 3, 12. And then you would, and that would be nothing. There's nothing left to come down. Yes. Yep, we saw how many times it went into 12. Say that again? Oh okay. So that means 672 divided by 3 is 224. Or that means 3 times 224 is 672. Mm-hmm. Yes. No whining. And it's the number one rule for the day. No whining. No whining. All right, let's try one that's a little longer. Some other things kind of happen with this one. All right, so start the same way. How many times does 4 go into 1? It doesn't go into 1, but it goes into 12s, right? I had to use the 2 digits. Okay, how many times does 4 go into 12? 3 times. No. 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 Technically you could, but don't. Okay, don't. We're going to be talking about variables. You don't want to throw random x's in there. Yeah.
Okay, so you're going to multiply, you're going to get the 12, you're going to write 1, 200.
Yep. And then I'm going to subtract. Behind here?
Yes.
No. That would imply like 1,200,000. Don't do that. Don't do that. All right, so that's nothing, right? So then we're going to drop down the 5. The process starts again. Again, I want you to see the process here, okay? So how many times does 4 go into 5? Once. And then you multiply 1 times 4. And then you subtract, and we get 1. Bring down the next number. We start again. How many times does 4 go into 13? 3 times. We brought down just one thing at a time. 5 minus 4 was 1, and then I brought down the next number. Yep. They'll come down eventually. Don't bring everything down at once or you're going to confuse yourself on basic long division. So we get 12. And then you subtract. 13 minus 12 is 1. So I have a 1. I'm going to bring down the 6. So now I'm just dealing with 16. If I brought them all down, how many times does 4 go into like 1,600 and something? I don't know. So we just deal with little bits at a time, okay? So how many times does 4 go into 16? That goes in 4 times. And then you multiply 4 times 4. And then we subtract. That's nothing. Bring down the 3. Hold on, guys. Hold on. I don't want to lose people. How many times does 4 go into 3? None. So we have to put a 0 up there. 0 times 4. 0. And then we subtract. 3 minus 0 is 3. And bring down the 5. You had to put the 0 up there because 4 did not go into 3. You have to put the 0.
Because it's not the first number in the problem.
Right. So how many times does 4 go into 35? 8. Yep. 8 times 4 is 32. I'm running out of space. And then we subtract, and I get 3. I have no more numbers to bring down, and I know it. I could turn this into a decimal, but you know me in decimals. No. So remainder of 3. Does anybody know how you write remainder of 3? Not a giant R. We're not in 2nd grade. It's not a radical. It is 3/4. It's 3, and then whatever it was you were dividing by. 3/4. Right, so that divided by 4 is 313,408 and 3/4.
So what if it was like a 5?
If you were dividing by a 5,
What if it was a 5?
then 4 would go into 5 one time.
Right.
It means you wouldn't have made it, you wouldn't have used the biggest number.
Oh.
Yeah, it means you wouldn't have used the biggest number.
If you're dividing by like somehow dividing by 12, and you would
You would just write it as a fraction. Yeah, whatever that remainder is, put it over whatever it is you're dividing by. All right, now guys, I'm going to tell you right now, in all my years of teaching this, I've taught for a lot of years. I've never had a student not be able to do this. I'm sorry, don't do that. All right, so guys, nobody panic. No whining, no complaining, no panicking. I promise you, you will be fine. Get through a couple, understanding the process. We'll practice this. You'll be fine. Everybody okay? We're not going to panic. We're not going to panic. And sometimes people find it easier to do it with variables than they do just the regular numbers. So let's try with variables and see what you think. Okay? So divide, use long division. Yes. So what is f of x? It's like y. Okay, so do I really need to worry about that? No. I'm taking this and dividing it by that. So the first thing I want you to do is actually, let's just set this up. Make sure you leave space above for your actual answer up here. So I'm doing 6x squared plus 7x plus 2 divided by 2x plus 1. All right, I want those of you that like to answer every single question I ask, I'm going to ask you to resist that today, okay? All right, because I want to make sure I don't lose people by we're just throwing random things out today. All right, so just like before, where we looked at just like the first numbers, same thing here. I'm only looking at first number. Okay, that's all I'm starting with, just looking at first part. What do you, instead of me asking how many times does this go into it, I'm just going to kind of change that wording. What do you multiply 2x by to get 6x squared? 3x. That's what goes up top. Okay, now think back to the other problems we did. What was your next step? We multiplied. Now, this is where I can get this plus 1 part back into the game. Okay, I have to distribute this to both parts. I'm distributing. So 3x times 2x is 6x squared. And then 3x times 1 is a positive 3x. Okay, you guys with me so far? Okay. If you're going to mess up anywhere, it is right here. What was your next step before? It was subtracting. Now, what happens when I am subtracting an entire piece like this? You have to distribute the negative. So what happens to all your signs? They all change. So instead of saying subtract, you're going to hear me say change your signs. That, if you're going to mess up anywhere, that's where it's going to be. You're going to forget to change all those signs.
So they don't change the original equation?
Nope, just in whatever it is you're subtracting. It will always, if it's negative to begin with, it'll be positive. Yep. Yep, because that's what should happen, is this should cancel out. 6x squared minus 6x squared. No. And then 7x minus 3x is 4x. What was my next step then before? I brought stuff down. And the whole process started over again. Bless you. So again, only the first part. What do you multiply 2x to get 4x? Just 2. A positive 2. And then what do? We distribute. 2 times 2x and 2 times 1 plus 2. And then we have to change your signs. So that becomes a minus. That becomes a minus. You're right, and they both cancel out. So is there a remainder? No. It's 3x plus 2. Now, that's your main process. Now, there's some bumps in the road from some other things that will show up, but that's your main process. Now, what does it mean? So yeah, it means this divided by that is that, but that means 2x plus 1 times 3x plus 2 is 6x squared. So what did I just do? I just factored it. I gave you one of the factors and you just factored it. Kind of cool though, right? All right, let's try another one. Let's just make sure. We're going to do a bunch of these today. This is the goal for today. It's just long division. So we're going to do a few more together before I kind of let you go for a minute. All right, so let's set it up first. So x cubed plus 5x squared minus 7x plus 2 divided by x minus 2. Yeah. Is yours straight? That's fine. That's fine. I'm not going to be that particular. Yeah, don't make a check mark or that's going to be a radical sign. But no, I'm not that particular. No, it's fine. Just my brain has been trained that it's curved. All right. So again, we're starting with just the first numbers. What do you multiply x to get x cubed? X squared. Now, guys, a little red flag for you. Every problem I give you should be a fairly simple multiply here, right? Like I shouldn't have to have like a fraction up here to get it to work. Okay, so if that happens, you did something wrong somewhere. Sam? Yes. Yeah. Okay, so what's my next step once I figure that out? Distribute. So x squared times x is x cubed. X squared times negative 2. Negative 2x squared? It's all right. Okay, what's your next step? Change your signs. And again, if you're going to mess up anywhere, it's going to be right there. So this one becomes a minus. That one's going to become a plus. Now, if it helps you, I've had students in the past, they'll keep like a colored pen next to them, and they always change their signs in colored pen. Sometimes it helps them to see that change. Do me a favor. Some students think they're real smart, and they like try to change them like while they're writing them down. Don't do that. You're going to make mistakes, okay? Even me, as much math experience as I have, if you look at any answer key I make, I will write them down, and then I go back and I change them. No, I'm not on this one because it's too easy to make a mistake. All right, so x cubed for making mistakes. Oh yeah, people make all kinds of crazy mistakes on these. So x cubed minus x cubed. If that doesn't cancel, what happened? You did something wrong because it should. And then 5x squared plus 2x squared, 7x squared. And then I'm going to go ahead and bring all of this down. Only because sometimes, and you'll see in problems coming up, sometimes things don't line up perfectly, and it's just easier to see it all on one line. And then our process starts again, though. So what do you multiply x by to get 7x squared? Positive 7x. Yeah, because you're making a polynomial at the top, so you need your pluses or minuses depending on what you need. Okay, so then we distribute 7x times x. And then 7x times negative 2. Negative 14x. I'm sorry, what was your question, Adrian? You okay? Okay. What's your next step? Change your sign. So I'm going to change that one, change that one. You're always changing the signs on whatever you just wrote down, the newest thing you put. 7x squared minus 7x squared cancels, as it should. Negative 7x plus 14x. And then I'm going to bring down the plus 2. Do you see where basic math could cause a major issue? Yeah. And that's usually if you mess up, it's you forgot to change your signs or your basic math, which is where some of you lose all your points anyways, basic math. All right. How do I know whether I'm done or not? Do I keep going? Yeah, as long as you can still multiply to get, you keep going. Once you hit a point where I can't multiply to get that number anymore, I'm out. I'm done. What do you multiply x to get 7x? 7. Positive 7. And then we distribute 7 times x. 7 times negative 2. What's wrong? Because I was seeing what do we multiply x by to get 7x? You just multiply it by. Yeah, we were trying to make 7x squared on that one. So I needed to multiply by another 7x to make it x squared. All right, where am I at? What's my next step? Change my signs. So then my 7x's cancel. And then 2 plus 14, 16. What do you multiply x to get 16? You can't, right? It doesn't have an x on it. So that means I'm done. So once I hit a point like that where my x's and all that don't line up, I'm done. So this is my remainder. You always add on your remainders. And it's going to be 16 over what you're dividing by, x minus 2. Now, I'm going to tell you right now, if you are working through a problem and you get a wrong answer and you ask me to, like, what did I do wrong? I will help you, but it's going to take me a minute, okay? Because there's a lot of sign changing and everything else going on. It takes me a minute to find your mistakes. Yes. You knew that was coming, right? Now, the ones that I'll have you guys solve, they'll not be quite as ugly. But right now, our goal is, yeah, it's okay. We got a whole chapter on those coming up next. All right, but guys, goal for today is, can you do long division? That's the whole goal. All right, now this one's written slightly different. What's a fraction bar mean? It means divide by. Yeah, it just means divide. Yeah. So it's the same idea. Except what am I dividing by this time? I have 3 things I'm dividing by now, 3 pieces. So when you set this up, this means this whole top part is being divided by the bottom one. No. So rewrite it into our Radican form, okay? That's going to keep things way easier. But just so you know, a fraction, it just means divide. All right, we're dividing that by x squared minus 3x plus 5. Yes. Good question. Her question was, will they have problems that you have to put it in standard form first? Yes. Always make sure it's in standard form. If it's not, nothing's going to line up right. We don't have to worry about GCFs. Nope, we're not to worry about any of the factoring right now. Now, looking at the problem I have underneath my Radican, do you notice something's missing? The x squared is missing. This section, especially Monday when we do synthetic, you have to notice things are missing. So the x squared is missing, right? It went to the 4th, the 3rd, then it went to the 1st. So it's missing the x squared. A lot of times when there's that piece missing in here, not everything's going to line up nice and pretty. So just be aware, things may not line up nice. All right, well, we start right from the beginning. First numbers, the x and the 3x to the 4th. 3x squared. Good. What do you multiply x squared to get 3x to the 4th? 3x squared. And then we're going to have to multiply. So we're going to have to distribute to a lot of things. So 3x squared times x squared. 3x squared times negative 3x. Negative 9x cubed. 3x squared times 5. Then what do I do? Change your signs. Change, change, change. All right, before we move on to the next part, I want to make sure everybody's with me. Questions so far? Is it true that sometimes the polynomial ones are easier than regular numbers? Well, let's see what happens, okay? So 3x to the 4th minus 3x to the 4th cancels. Negative 5x cubed plus 9x cubed is 4x cubed. 4x minus 15x squared. Those aren't like terms, but can I continue to keep those in my problem? Yeah. make sure they're in standard form. Minus 15x squared plus 4x, and I have a minus 6. So be careful. Again, because that x squared was missing in the original problem, not everything lined up perfectly. So if they don't line up as like terms, that's fine. Just, you know, put them all in your problem. We'll just move on from there. It happens. Yeah. All right. So next step, what do you multiply x squared to get 4x cubed? 4x. Positive 4x. Okay. Then we distribute. 4x times x squared. 4x times negative 3x. 4x times 5. And then what do I do? Change my signs. Oh, I hear people changing pens. I think it helps. See those sign changes. It's nice to see them. All right, put your like terms together. 4x cubed minus 4x cubed. Negative 15x squared plus 12x squared. Negative 3x squared. 4x minus 20x. Negative 16x. And minus 6. And we start again. Keep going as far as you can. Just negative 3. Because what do you multiply x squared to get negative 3x squared? Just the negative 3. We already have the x squared part.
So if you already have it, then we don't need anything.
Right. Because my next step is going to be to multiply it. And if I had put an x squared here, x squared and x squared would make x to the 4th. So we already got that covered. All right. So the negative 3 times x squared. Negative 3x squared. Negative 3 times negative 3x. Positive 9x. And negative 3 times 5. Then what? Change my signs. Change, change, change. Whew. So my 3x squared's canceled though, right? Negative 16x minus 9x. Negative 25x. Negative 6 plus 15. It's a positive 9. Then we start again. What do you multiply x squared to get negative 25x? You can't. I can't make the x's smaller. So that's my remainder. So plus, and then my remainder, negative 25x, whoa, plus 9 over x squared minus 3x plus 5. Jonas? Oh, every time. Yep. Guys, the question came up, do I write a plus every time? And the answer is yes. Reason being, if you had just been like, oh, there's a minus there and stuck a minus in front of the entire parenthesis, what, or entire fraction, what does that imply for that entire fraction? That you would switch every sign in there, and we don't want to get into that. So if you always put a plus, you are always good. Okay? You guys ready to try one on your own? We can do this. I have faith in you guys. Always move it into standard form. So let me make sure we're okay setting up wise. So on number 4, guys, notice the top is not in standard form. Rewrite it in standard form. So 4x squared plus 23x minus 16 in standard form divided by x plus 5. All right, guys, let's go ahead and go through this. Walking around, they look fairly good, okay? Only a couple of you I'm real worried about. When Jonas comes back. All right, so your setup should have been here. At least one of you was talking when I was explaining standard form, right? They need to be in standard form. Or do they work? Yeah, they don't work, right? If they're not in standard form, you're like, whoa, this does not work at all. All right, so what do you multiply x to get 4x squared? 4x. And then we distributed 4x times x. And then 4x times 5. And then our next step is always change your signs. So the first one should cancel. If it doesn't, you did something wrong. 23x minus 20x is 3x. I'm going to bring down what I got left, and then the whole process starts over. So what do you multiply x to get 3x? Just 3. And some of you were like, do I need a 3x? But then x and x would make x squared, and then they wouldn't be like terms. So just a positive 3. Question? No. Because then you have to subtract or change your signs, and it would change them all back so nothing would cancel. Trust me, if there's a shortcut, I'm going to teach it to you. All right, so then I have 3 times x and 3 times 5. And then change your signs. First one cancels, as it should, and then that gives me negative 31. A couple of you had a few little issues with your remainder, right? You remember that I told you should always write plus and then whatever the remainder is. So it's still a negative 31 over x plus 5. A couple of you did not write it as a fraction. It just looks like it's part of your problem, so make sure you don't do that. And it's plus and then the negative 31 over x plus 5. Okay? We will be using this. Probably won't.
This is one of those ones that you never.
I mean, the job that you would probably have to have, I don't even know. So, state says you have to learn it. I'm going to teach it to you. It is exercise for your brain. Just like I go out and run, not because I want to be a marathon runner, but because it's exercise. So we're exercising your brain. It's problem solving, right? Yep, we sure can. All right, guys, number 5. So first, the part at the top, a polynomial is a factor if the remainder is 0. Yeah, because if the remainder is 0, that means that you could have actually factored it. Right? That was a factor of it. So it comes out nicely, right? Because it's always 2 days later that your legs hurt. Okay, so is x squared plus 1 a factor of all of that? So the only way we know is to actually divide it and see if there's a remainder. So let's divide it. If when you divide it and if there's no remainder, then it was a factor. So 3x to the 4th minus 4x cubed plus 12x squared plus 5. And again, all of this, guys, is baby steps to what I know is coming into the next couple sections, okay? This is like that building section in between. All right, so I have x squared plus 1. Did you notice anything is missing? Right, you're missing an x here, and what else am I missing? An x in between here, right? Because it's x squared, there's no plain x, and there's no plain x here. So things may not always line up pretty and perfect. Okay? All right, so what do you multiply x squared to get 3x to the 4th? 3x squared. All right, so 3x squared times x squared. Good, and then 3x squared times 1 is 3x squared. And then we change our signs. But do you see how methodical this is, though? It's like same process over and over and over. All right, and then my x to the 4th parts cancel. Now be careful. Lily? Yes. This and this, they're like terms. They just didn't line up. And again, it's because you got missing pieces in here that things didn't line up right. So the negative 4x cubed, we want to make sure it's always in standard form. But then these are like terms. 12x squared minus 3x squared, 9x squared. And then I have a plus 5. So again, just be aware. If you see that original problem, that there's pieces missing, chances are it won't line up right. All right, then we start over. What do you multiply x squared to get negative 4x cubed? Negative 4x, good. Negative 4x times x squared. Negative 4x cubed negative 4x times 1. Negative 4x. Then what? Where did I lose you? I did negative 4x times x squared. It's negative 4x cubed. I brought it down, but it's still my next thing I have to try to multiply to get. Okay, that's all right. No, I'm glad you asked. Change your signs. Thank you. They both changed to pluses. All right. These cancel. Good. I'm going to have a 9x squared plus 4x plus 5. I know, me too. We're almost done. All right, and then we start again. What do you multiply x squared to get 9x squared? 9? Where are you confused? What are we doing? Got that? All right, and then 9 times x squared. 9x squared. 9 times 1. 9. Adrian, can you grab the door, please? Don't you love sitting there? All right, and then we change your signs. So my 9x squares cancel. I have 4x and then a minus 4. I have 4x and then negative 9 and a positive 5 are like terms. They just didn't line up together. And that gives me negative 4. What do you do with the remainders? What sign do I always put up here? Plus my remainder, 4x minus 4, over x squared plus 1. So the question of, is x squared plus 1 a factor of that? No, it is not. Why is it not a factor? Because there's a remainder. Yep, if there's a remainder, it's not a factor. Just like if I asked you, is 3 a factor of 10? No, because does 3 divide into 10 evenly? No, there'd be a remainder. So that's not a factor. Yep. Stay tuned. What if I tell you, though, the only ones we'll be solving are the ones that divide with no remainder? Would that make you feel better? All right. Last one we're going to do today. And then we will actually come back to this problem when I teach you synthetic. Because I want you to see the difference. Yeah, this one you could use both methods work. You think maybe on the test it will just say divide and you have to decide which division to use? That's what I do. All right, so is x minus 2 a factor of x to the 5th minus 32? So to find out, we just divide, right? Right small. Right small. So x to the 5th minus 32 divided by x minus 2. You're like, what? They look so nice and so pretty. They're so small. Was anything missing? And yeah. Did you guys hear Jonas? I'm missing x to the 4th, x to the 3rd, x to the squared, x to the 1st. I'm missing 4 pieces in between there. Now, I'm glad that we're starting to see that because that'll make synthetic so much easier. Because if you don't see that with synthetic, it's going to be wrong. Okay? All right. But with long division, if you don't notice it, it's okay. You can still muddle through it. All right. What do you multiply x to get x to the 5th? X to the 4th. All right. Then we distribute. X to the 4th times x. X to the 4th times negative 2. Then what? Change your signs. My x to the 5ths cancel. Those aren't like terms, so I have 2x to the 4th minus 32. You guys with me? Okay, and then we start again. What do you multiply x to get 2x to the 4th? 2x cubed. Jonas, you okay? All right, 2x cubed times x. 2x to the 4th. And then 2x cubed times negative 2. Negative 4x cubed. And then change your signs. My x to the fourths cancel. Those aren't like terms, so I have 4x cubed minus 32. Isn't this fun? I think it is. Start again. What do you multiply x to get 4x cubed? 4x squared. Jonas, you think it's fun, don't you?
Yeah, no, I was gonna
Yeah,
ask
I know
you,
what we're
why
doing. We're
is
getting
it
all the
like
parts of
Yes, I did. Yeah. All right, so 4x squared times x. 4x squared times negative 2. And then? Nope. Change your signs. Some x cubes cancel. And I have 8x squared minus 32. And we start over. Bless you. What do you multiply x to get 8x squared? Thank you. 8x times x. 8x times negative 2. Negative 16x. Gotta watch those signs at all times. And then change your signs. Good. And then we have 16x minus 32. And then we start over again. Come on, this is fun. What do you multiply x to get 16x? 16. 16 times x. 16 times negative 2. And then we change our signs. Hey, they both canceled out. So is it a factor? Yes. Yeah, you keep going until you can't go any further. Oh, if so, write it as a product of two factors. Because then that means x minus 2 times x to the fourth plus 2x cubed plus 4x squared plus 8x plus 16 will give you x to the fifth minus 32. Now, the reason we're starting, I want you guys to kind of look a little into the future here. If I had just given you x to the fifth minus 32 and I said factor that and solve. If we have two terms, what's the only things that we deal with two terms? It's either difference of squares or sum and difference of cubes. Do I have anything for the fifth? I don't. So if I had given that to you and I was just like, here you go, solve that, you'd have no idea how to solve that. Chapter 5. Okay, so that's kind of where we're stepping to. We're going to get things like this, and I want to ask you to solve that. And I will absolutely ask you to solve that in the next couple sections from now. Okay, but we need baby steps to get us there. Okay. Now, since I did find this was given to us, we found out that was a factor. Now I'm down to 1, 2, 3, 4, 5 terms. Do I factor with 5 terms yet? No. But what if I had given you another factor that you could have divided out? Then if you had 4 terms, could you maybe factor that? You could maybe do grouping. So we're eventually going to get to the point where like things will be given to us, or we'll find factors on the graphing calculator by looking at the graphs. And then we'll be able to use some dividing, some whatnot, to turn it into something that I can then factor and solve. Okay? That's kind of where we're going with this, just so you guys know.